What is the difference between planar and spatial kinematics? Have you ever wondered how mechanical systems move? Today, we will break down the differences between planar and spatial kinematics. Understanding these concepts is essential for anyone interested in mechanical engineering. Planar kinematics focuses on motion within a single two-dimensional plane. This means that all components of a system move in parallel planes or within one flat surface. Because of this limitation, the analysis and design of planar mechanisms are much simpler. Typically, these systems have 2 degrees of freedom, allowing for rotation and translation. A great example of planar kinematics is the piston connecting rod crankshaft assembly found in internal combustion engines. Another common example is the 4-bar linkage, often used in fixture clamps. On the flip side, spatial kinematics deals with motion in 3-dimensional space. This allows components to move in various planes and orientations, leading to more complex motion patterns. Spatial mechanisms generally have 3 degrees of freedom, which means they can move along and around multiple axes. Some examples include universal joints, robotic arms, and camera gimbals. These systems provide greater flexibility and functionality, especially in applications like robotics and aerospace. From a mechanical engineering viewpoint, planar mechanisms are easier to visualize and analyze due to their 2-dimensional constraints. In contrast, spatial mechanisms requiring advanced mathematical tools, such as vector calculus and matrix algebra, to accurately describe their motion. This complexity makes designing and analyzing spatial mechanisms more challenging, but it also opens up a world of possibilities for engineers. In summary, planar kinematics is all about motion confined to a single plane, making it simpler and more straightforward. It typically features 2 degrees of freedom. Spatial kinematics, however, involves motion in 3-dimensional space, with more complexity and 3 degrees of freedom. Understanding these differences is key for mechanical engineers when selecting or designing mechanisms for specific tasks. Whether you need simplicity or flexibility, knowing the distinction between planar and spatial kinematics will help you make informed decisions in your projects.